Welcome to this deep dive, where we are going to completely map out how to protect your enterprise data against, well, invisible threats.
Yeah, the kinds of threats that your multi-million-dollar security stack doesn't even know are there.
Exactly. I mean, usually when we talk about enterprise security, you expect this fortress mentality, right? You picture a massive, impenetrable castle.
Right, the classic perimeter model.
Yeah. You spend tens of millions locking the front door. You've got, retinal scanners at the data center, biometric identity checks, heavy steel vault doors.
And the endpoint security is locked down so tight that, like, an employee can't even plug a USB drive into their laptop without triggering 3 different alarms.
Exactly. 3 alarms in the security operations center just for a thumb drive.
Yeah.
But then, you step into the actual day-to-day operations of a modern, fast-moving company.
And that physical fortress metaphor just falls apart.
It really does. You look past the firewall dashboards, and you watch how a marketing associate actually does their job. And suddenly you realize while you were checking badges at the front gate, that marketing associate just went up to the second floor, popped open a window, and built a server-to-server zip line right out to an unvetted AI app.
A zip line that the guards at the front door can't even see.
Right, and they are just sending buckets of highly sensitive customer data down that zip line 24 hours a day. So our mission today, for you listening, is to unpack all of this.
We need to figure out how to stop these unseen server-side API extraction threats.
Yeah, often known as shadow pipelines. And to do that, we've got an incredible stack of sources today. We're pulling from the 2025 Gartner Magic Quadrant for Security Service Edge, featuring Palo Alto Networks.
We're also looking at the SailPoint Market Guide for Identity Governance, IBM's MOS 360 Mobile Threat Defense Architecture, and the OSP Top 10 CI/CD Security Risks.
Plus, we've got a really foundational piece by Prasad Pandey on securing low-code, no-code shadow pipelines. So, okay, let's unpack this.
Let's do it.
The illusion of the perimeter. We mentioned this zip line analogy, but let's look at the concept of low-code, no-code, or LCNC shadow pipelines.
Wow, because the driving force behind this isn't some malicious hacker. It's actually just business velocity.
Yeah, it's just a non-technical employee, like a senior account executive, right? They're under massive pressure to close deals, and they want to work faster.
They want to, say, summarize 100 pages of client meeting notes that are sitting inside your highly secure Salesforce CRM.
But the internal tools are just too clunky. So they use something consumer-friendly, like Zapier or Make.com.
And the friction to use those tools is virtually zero. I mean, they don't write a single line of code.
No, not at all. They just log in with their corporate credentials, click a button that says Allow Access, and hit Save.
And boom, the shadow pipeline is fully operational, the data is flowing.
But wait, if the data inside that CRM is highly sensitive, like if it contains PII, why doesn't our data loss prevention system catch it? I mean, we pay fortunes for DLPs to stop this exact thing.
Well, to understand why the DLP is totally blind here, you have to look at the routing. Where is the data actually moving?
Okay, so where is it moving?
Your DLP agents and your firewalls, they sit on the corporate network and on the physical laptop, right?
Right.
But this data extraction isn't happening on the laptop. It's happening strictly API to API in the cloud.
Oh, wow. So it's like having the TSA heavily guard the front doors of the airport, meticulously checking luggage.
Yeah, perfect analogy.
But meanwhile, 2 airplanes are just flying next to each other at 30,000 feet, and they just open their cargo doors and throw the bags across the gap.
Exactly. The TSA down at the terminal never even sees the bags move. The data goes straight from the Salesforce data center to the AI summarizer's server.
So the corporate network never processes a single packet.
Not one. The webhook triggers an event in the cloud. The SaaS platforms talk directly to each other over the public internet, and the payload is delivered.
And my endpoint security is basically asleep.
It's fast asleep. Because from the laptop's perspective, the CPU and the network card are totally idle. It's not downloading data locally and then uploading it to an AI tool.
It's cutting the laptop out of the loop entirely, which creates this massive silent compliance failure.
A huge failure. You've got intellectual property, GDPR-protected data just continuously exiting your environment.
And the employee isn't even doing it maliciously. There's that principle from the sources, data flows where resistance is lowest.
Right. They just want their automated pipeline summaries. But the consequences, unregulated webhooks draining your enterprise IP, while the security dashboard shows nothing but green lights.
Okay, so if we can't see the data moving across our network, we have to look at the permissions that actually enable that movement in the first place, right?
Exactly. And this brings us to a really important paradigm shift. It's called restorative engineering.
Restorative engineering. Okay, what does that mean in practice?
It's a philosophy that says, look, you own the corporate data. Therefore, you must take back control of the pathways that data takes, no matter where they are in the cloud.
So how do security operators actually do that?
They have to stop looking at network packets. Instead, they need to plug directly into the OAuth token registries of their major SaaS platforms.
Okay, let's pause and dissect what an OAuth token actually is, just for anyone who isn't a cloud architect.
Sure, think of it like a valet key for your car.
Right, because when you go to a restaurant, you don't give the valet the master key to your house. You just give them a specific key that only lets them drive the car a short distance.
That's exactly right. In the digital world, when that marketing associate clicked Allow Access for Zapier, Salesforce didn't hand over the employee's actual password.
It generated an OAuth token.
Yes, a cryptographic string that says, Zapier is allowed to perform these specific actions on behalf of this specific user.
But the problem with these LCNC tools is that employees are, accidentally giving the valet the master key.
They really are, because they don't read the permission scopes. They just click Allow.
So a simple calendar app suddenly gets read and write access to the entire corporate email directory.
Precisely. And those tokens are persistent. They live in the background working 24/7 long after the laptop is closed.
So to fix this, we have to run an API governance audit.
Yes. Security teams use specialized tools to continuously scan those token registries in platforms like Google Workspace or Microsoft 365, hunting for active webhooks tied to unvetted domains.
Okay, but let me push back here. Let's say we run that scan and we find 2,000 rogue API connections. If I just deploy a kill switch and mass revoke every single token,
You're going to break the business.
yeah, the revenue team will absolutely revolt because I just broke their automated billing workflow right at the end of the quarter.
And that is the fastest way for a CISO to lose their job. You can't treat every shadow pipeline like a 5-alarm fire.
So how do we handle it?
You have to prioritize remediation by mapping it to specific business risks. You need context, which is where modern identity governance and administration, or IGA, comes in.
Like the SailPoint framework we have in the sources.
Exactly. SailPoint uses AI to provide that context. Let's say your audit flags 2 things. First, a manager syncing their Microsoft Calendar to a mobile Apple Watch app.
It's unsanctioned, sure, but the payload is just meeting times. Very low business risk.
Right. But the second flag is an open source AI document analyzer that somehow got read-write access to the legal department's shared Google Drive.
Oh, wow. Yeah, that is pulling down unredacted vendor contracts and NDAs. That's an existential compliance risk.
So the AI-driven IGA platform analyzes the context. Who is the user? What is the data source? What are the permissions?
And it calculates a critical risk score for the AI tool, but a low score for the calendar sync.
Exactly. You let the calendar sync live for a bit, maybe schedule a manual review, but you prioritize the legal department's data bleed for an immediate kill switch.
Okay, I want to narrate this. Let's walk through a step-by-step incident response scenario. I'm sitting at the security operations console. An alert flashes. What happens?
Step 1 is detection. Your API scanner sees a user in legal just authorized Summarize Bot Pro to access their drive.
The valet key is handed over. What's step 2?
Contextual evaluation. The system references the IGA parameters. It sees the app isn't on the approved vendor list, and the permissions are way too broad.
So the risk score hits the critical threshold. Step 3 is the kill switch, right? But how does that actually work technically?
Well, you can't block an IP address on your firewall because cloud IPs change all the time, so you have to destroy the trust relationship.
How?
The security platform sends an automated API callback to the Google Workspace admin console. It instructs Google to forcibly revoke that specific OAuth token.
So you're calling the valet stand and saying, hey, that key is void, don't give them the car.
Yes, the token is digitally shredded. Milliseconds later, when the bot tries to pull down a contract, the Google server returns an HTTP 401 unauthorized error.
The zip line is cut at the anchor point, and this all happens in seconds.
Without a human operator needing to frantically click through 20 administrative menus, yes.
That is incredibly powerful, but, it introduces a massive human factors problem.
The interface design.
Yeah. I mean, if you have 50,000 employees, you're generating tens of thousands of tokens and alerts. Traditional dashboards look like a chaotic Reddit thread where everyone is shouting in all caps.
Blinking yellow lights everywhere, scrolling text. It's a cognitive overload nightmare.
If everything is marked critical, nothing is. The operator is going to suffer from alert fatigue.
Which delays remediation. This is where we bring in the design principles of Dieter Rams to simplify these complex security interfaces.
Right, Dieter Rams. For the listener, he's the legendary industrial designer from Braun. He practically invented modern minimalism. Less, but better.
And applying that to a high-stakes cybersecurity interface is brilliant. In a crisis, you have to eliminate visual friction.
It's like moving from a chaotic airplane cockpit full of hundreds of dials to just a sleek, singular warning indicator. So what does this dashboard actually look like?
Imagine a stark, expansive white background. The negative space gives the eye room to rest. In the center, you have two simple, matte black geometric blocks representing servers.
Okay, one block is our sanctioned Salesforce server, and the other is the unauthorized AI tool.
Exactly. And beneath them is a horizontal translucent barrier, like frosted glass, that represents your traditional firewall.
But the threat isn't touching the glass.
No. There's a single, thin, brightly glowing crimson line that arcs directly from the top of the Salesforce block to the AI block. It bypasses the glass entirely.
That is so clear. You instantly understand the physical nature of the server-side bypass just by looking at it. No distracting menus.
Right. And then you have the audit UI. When you need to dive into the logs, the interface switches to dark mode. Rows of hex codes scrolling vertically.
The operator doesn't have to hunt for the bad code, right?
No, the AI stops the scroll, and a stark red bounding box snaps into place, isolating the exact rogue OAuth token string. The text turns from gray to bright red.
And finally, the kill switch UI. How do we visualize that?
It's this abstract industrial visualization, a macro close-up of a taut, braided steel wire. When you authorize the kill switch, a heavy matte black mechanical blade descends and severs the wire.
The tension snaps. It's so visceral. Using materials like anodized aluminum and braided steel communicates weight and action without needing explanatory text.
It massively reduces cognitive load, allowing for instant, precise action.
Okay, so we've got the bypass visualized and we've got the kill switch ready. But stopping live pipelines is inherently reactive, right? The data has already started to flow.
Yes, the webhook was already active.
So how do we transition to being proactive? How do we stop developers from building these shadow pipelines in the first place?
We have to shift our focus left. We need to look at the very foundation of software deployment, the CI/CD pipeline.
Continuous integration and continuous deployment. And this is where the OWASP top 10 CI/CD security risks come in. The attack surface here has evolved so fast.
Developers aren't building monolithic apps entirely in-house anymore. They're relying heavily on external dependencies, open source libraries, external logging providers.
And that speed and flexibility have opened up devastating avenues for attackers. Look at the SolarWinds compromise. That wasn't just a phishing email.
Far from it. It was a masterclass in compromising the CI/CD pipeline. The attackers injected malware directly into the build environment.
So while the legitimate code was compiling, the malware just silently swapped in a backdoor.
Exactly. And then it was digitally signed with a valid certificate and pushed out to 18,000 enterprise customers.
Terrifying. Or the code cuff breach mentioned in the text.
Yeah.
Attackers modified a bash uploader script used in the CI/CD pipeline.
And that modified script just quietly extracted all the environment variables like AWS access keys and API tokens and sent them to the attackers.
They vacuumed up the master keys to thousands of networks. And then there's dependency confusion. This one is insidious. How does an attacker trick a build system into downloading malware?
Let's say you have an internal package called offscript internal. It's private. An attacker finds that name, goes to a public repository like NPM, and creates a malicious package with the exact same name.
But how do they make your system download the bad public one instead of the safe private one?
They give the malicious public package an artificially high version number, like version 99.0.
Oh, and package managers are designed to pull the newest version by default.
Right, so your automated CI/CD system just happily pulls the malware straight into your secure code base, bypassing the firewall entirely.
Wow. Okay, so knowing these risks exist, how do we bake automated OAuth tokens scanning directly into the CI/CD workflow? Because developers need to ship code fast. If we add manual review gates, they'll just bypass us.
You don't use manual gates. You make security native and instant within the pipeline. Security becomes code.
So we monitor for things like inadequate identity and access management. That's CI/CD SCC2, right?
Yes, and insufficient flow control mechanisms, which is SEC1. Let's say developer writes a microservice that needs to send data to an external SaaS provider.
They commit code that introduces a new API key for a webhook.
The moment they push that commit, the CI/CD system triggers an automated static code analysis tuned for API governance.
It's like a spell checker, but for security policies.
Exactly. It checks if the vendor is approved. It checks if the webhook requests excessively broad permissions. It checks if API keys are hard-coded in plain text.
And if the code fails,
The build immediately fails. The pipeline stops. The developer gets a Slack alert explaining exactly what policy they violated and how to fix it.
so you treat third-party webhooks as untrusted code dependencies. That totally neutralizes the threat before it's ever deployed to a live server.
It's a zero-trust approach for code.
Okay, so we've secured the cloud runtime environment with kill switches, and we've locked down the CI/CD pipeline. But here's where it gets really interesting.
We still have to deal with the human and the physical endpoint.
Exactly. The employee is still sitting at a coffee shop with a vulnerable mobile device. The endpoint might be bypassed by the webhook, but the endpoint itself is the beachhead, right?
It absolutely is. This is where integrating mobile threat defense, or MTD, is critical. We're looking at IBM MAS 360's architecture here.
Let's trace the attack chain. An employee connects to a public, unencrypted Wi-Fi network at an airport.
And an attacker on that same network executes a man-in-the-middle attack. They broadcast a fake Wi-Fi signal.
And when the employee connects all their traffic routes through the attacker's laptop, the attacker intercepts the TLS handshake and presents a fake security certificate.
So when the employee logs into Salesforce, the attacker steals their username, password, and session cookie.
And then the attacker uses those credentials to log in from their own machine and build a permanent shadow pipeline, generating a malicious OAuth token.
Right. The initial compromise happens on the phone, but the exfiltration happens via the server-side bypass. That's why MTD is foundational.
But traditional mobile antivirus is too slow for that, isn't it?
Yeah, signature-based antivirus is dead. Modern MTD relies on frictionless deployment and localized intelligence. IBM highlights zero-touch activation.
So IT just activates it from a central portal,
Yeah.
and it deploys silently without the user doing anything.
Exactly. And once active, it uses an on-device AI-powered dynamic detection engine.
On-device is key for privacy, right? It's not sending all my web traffic back to IBM.
No, the machine learning models run locally on the phone's processor. It constantly analyzes network behavior in near real time.
So in our airport scenario, the AI sees the fake certificate and realizes the TLS handshake is being intercepted.
And it instantly flags the network, automatically severs the Wi-Fi connection, or forces a secure VPN tunnel to deploy all before the employee even types their password.
That's incredible. And it handles both work and personal profiles, right? Because
Sure.
people use corporate iPads for personal stuff all the time.
It uses containerization. It segregates personal data from corporate data, maintaining strict security over the work profile without violating employee privacy.
But the real magic is the telemetry, right? The mobile device feeds data back into the central CM or XDR platform.
Unified visibility, that's the holy grail. The security team can correlate a phishing link clicked on the phone at 10 a.m. with a rogue OAuth token generated in the cloud at 10:05 a.m.
You see the full narrative of the attack in real time. Okay, so we have this incredibly robust technical architecture, but here is the ultimate challenge.
Translating it for the executives.
Yes. How do we present these findings to stakeholders? If you walk into a boardroom and start talking about OAuth tokens and TLS handshakes, you're going to lose your budget approval in 30 seconds.
You absolutely will. You need an executive playbook focused on strategy, education, and risk reporting.
Let's start with educating the non-technical staff. The marketing associate building the Zapier zipline doesn't understand the risk. How do we teach them without a week-long boot camp?
We give them a very simple checklist. It's a behavioral shift. 3 questions they have to ask before clicking Allow Access.
Okay, teaching them to read the warning label on the digital zipline. What's question 1?
Permissions. Is this app asking for read-write access to the core CRM? If a simple calendar widget wants to delete customer data, that's a massive red flag.
Question 2.
Verification. Is this tool on the approved vendor list? If you just found it in a LinkedIn ad, stop immediately.
And question 3, which I think is the most important, intent.
Right. Question the necessity of the automation. Is saving 3 minutes of typing really worth exposing our entire client database to an unknown server?
It's about empowering managers to be the first line of defense. But what about the executive briefing? What's the CISO level strategy to present to the board?
3 business-focused steps. Step 1, define the threat in physical terms.
So, no jargon, just our firewalls protect the laptops, but our data is bypassing them in the cloud, leaking through third-party APIs.
Exactly. Step 2, introduce restorative engineering, but frame it as taking back ownership of corporate assets. We are going to actively govern the pathways our data takes.
And step 3,
Present the unified architecture, integrating identity governance and endpoint security to verify users and automatically sever unauthorized connections.
but the C-suite often hears security and thinks, slow down. We have to prove that we can be secure without sacrificing productivity.
This is where the Gartner SSE metrics for Palo Alto Network's Prisma Access are so useful. You pitch operational resiliency.
You highlight the scale. Precision AI stopping 30.9 billion threats daily.
You show them it reduces data breaches by 50%. You highlight the 99.999% uptime guarantees, avoiding costly outages.
And the performance metrics. You show them that this architecture actually creates a 5x faster app experience compared to routing everything directly to the public internet.
Exactly. You prove with data that native security is actually an enabler for the business, not a roadblock.
What a phenomenal synthesis of all these sources. I mean, we started out looking at the illusion of the physical perimeter.
We realize the data isn't in the vault, it's in motion.
It's a massive shift in philosophy.
Right.
We have to own the pathways.
Yeah.
By integrating automated API governance, minimal DRAMs-inspired dashboards, CI/CD controls, and mobile telemetry. We transition from being victims of the cloud to active architects of our data sovereignty.
We really do. But
Yeah.
there's one final provocative thought I want to leave you with.
Oh, lay it on us.
Everything we've discussed today assumes that a human employee is the one initially building these showered pipelines, a person clicking allow access.
Right.
But as AI agents become increasingly autonomous, how long until these AI agents start negotiating complex API connections with each other on behalf of our employees?
Oh, wow. AI to AI shadow pipelines. The valet literally handing the keys to another valet.
Exactly. How long until the pipelines are built and expanded entirely by machines, routing data in milliseconds, way faster than any human-designed audit can keep up with?
Wait, really? How do you even govern the zip line when machines are building them in the dark?
Faster than you can even render the dashboard. It's something we're going to have to face very soon.
That is a deeply terrifying but utterly fascinating thought to sit with. And we'll let you, the listener, explore that one on your own. Thank you so much for joining us on this deep dive.